Hello again, this is Randy back in the shop today. Today I'm going to be working on the fuel mixer for the hit and miss engine here. I got it set up in the mill. I'll show you the drawing here a second. Okay, here's the drawing for the fuel mixer, and what I need to do first is I need to bore this diameter to 450 thousandths. Then I need to drill a 1/4 inch hole through to this port, and then I need to drill and ream an 1/8 inch hole all the way through to the bottom. So that's the plan anyway. They're calling for a 45-degree angle here, which should be 90 total, but I don't have a 90-degree countersink small enough to fit in this bore. It's got to be smaller than 450, and they want the top edge of it 7/16, which would be 437 across the top. So what I did is I took a 437 drill bit here, and I got my drill grinder out, and I ground it for 90 degrees. So it's 45 degrees on each side, 90 degrees included angle. And I'm going to use this to create that seat in the mixer casting. So let's head on over to the mill and we'll get started. All right. This is my setup here. I got a boring head set up in the mill with a small boring bar here, and I got the mixer clamped on the rotary table, and it's zeroed under the spindle. So I'm going to take and loosen up the lock here on the side of it, and I want to take about 3 thousandths. There's 3 right there. I have a dial indicator on the back side of this so I can measure how much I'm moving it. This is an old Bridgeport boring head, and I think it measures 1:1 rather than the actual bore size, how much you increase the bore size. So I haven't used it yet. This is the first time using it, so let's give it a crack and see how it goes. Okay, here we go. Just about cleaned up. We'll give it a little more here. Okay, I gave it another 3 thousandths, which should be 5 total, or 6 total. So let's make a pass through there and then measure the bore again. Lower the table down here so I can get my snap gauge in. Okay. Sorry about having my arm in the way here, but the only way I could do it. Draw that through there, and we'll see where I'm at here. Looks like I'm at 410, and I got to go to 450. So we got a ways to go. Okay, our hole diameter was 410 thousandths, and I took another 7, which should put it at 425. 7 on one side, so you double it, so it's 15. A little over 7. Okay, let this back down here. All right. Get a measurement here again. Yeah, we're at 424 and a couple of tenths, so I'll raise this table back up, make an adjustment to the boring head, we'll bore it again. Okay, I made another adjustment to the boring head here. Took another 7.5, so that should put it at 440 thousandths in diameter, my hole. Yeah, we're just about half thousand shy of 440. Okay, this should be the last pass here. I'm taking 7.5 thousandths. All right, I'm gonna lower this back down, take another measurement. Get our snap gauge back in the bore. Tighten it up. And we'll see where we're at. Run this through there again. Maybe a tenth or two over 450. So that's good. Now what I have to do is I have to put a 1/4-inch drill in. I need to drill through till I break through into this cord port here. All right, I got a long spot drill here. I'm going to spot a hole here in the bottom of this. Then I need to take the 1/4-inch drill and drill through to this port on the side here. And my 1/4-inch drill. Now I'm going to put the center drill back in. I'm going to put a center at the bottom of this core hole here. Then I need to take an 1/8 inch drill and drill the rest of the way through. Take the air hose and blow these chips out of there. Now what I gotta see if I got a longer 1/8 inch drill. It's not gonna be 1/8 inch, it's gonna be one size under 1/8 inch. And this drill should just be long enough. Take a nice slow. Good stuff here. I'm gonna have to extend my drill a little bit here. Extend this drill bit out a little bit. Okay, I got the 1/8 inch reamer here. Here we go. What I've done on this drill bit here is I went ahead and put Dykem on it, and then hopefully I'll be able to see on the edge where it's worn away where I'm drilling, because this is exactly 7/16, and you want the top edge of that seat 7/16 wide. Okay, here we go. see if it's touching yet. Should be. Yeah, it looks like it is. Yep, just touching. Okay. I raised it 10 thousandths. See what that's looking like here. Yeah. Appears to be working. Lower this back down to my stop. There's 20. Blow that drill bit off here a little bit once so I can see it. See where it's wore the dicom off. Okay. I think I'm there. The dicom is worn off almost to the edge of the drill, as you can see. Move the camera here so you can see that seat. There's the seat that I cut right there. Now this hole here needs to get tapped half 20, half-inch National Fine. A little bit of tap magic on there. I'm just going to tap it by hand. Looks like we got it. And what I need to do is from this boss here to the top, it needs to be 510 thousandths. Okay, what I'm doing here is I got a 5 thousandths feeler gauge, and I'm running that in between there till the end mill just touches it. And I'm going to lower the table. Being it's got to be 510, I'm going to go 505 because this is 5 thousandths thick. Okay, I got everything set here. I got to come up 132 thousandths. Right here. Okay. Now I think everything on the top here is done. All right, still working on the fuel mixer body here. I got a spot face or counter spot drill a hole here. And then I got to take a letter D drill and drill down 5/16 of an inch for 16th pipe thread tap. And we'll come up 3/16 of an inch, or 5/16, which is 3/12. Right here. Now I got to take a 3/32 drill. I got to drill a hole in the center of this hole right here down to this port down over here, which is your it's where the needle valve is in. This will allow fuel to flow past the needle valve into the motor. Okay, I'll get a 16 pipe tap and we'll get that tapped. Grab my tap wrench. That's as far as it goes. Blow this out here. Got a 16th pipe plug here. We'll see. I'll double check, see how it fits. Could stand to go down a little more. Let me grab a different pipe tap here. I ran another pipe tap through here, and it's the plug went into it about halfway. That should be good. Okay, I got this Boss machined off here to the proper height, and now I need to put a 200 thousandths deep counter bore in there, 281 thousandths in diameter. So I have a 281 2-flute end mill. We're gonna plunge down 200 thousandths. There's 100. $200 right there. Okay, I think all the machining on this part is done. Okay, here's the completed casting for the fuel mixer. This is your fuel inlet here. There's a flow control valve that I have to make that goes right here. And see if you can see that little tiny hole. There's a little tiny hole in the bottom of it. That's a 35 thousandths diameter hole, number 65 drill, and it needed to land in the center of that 45-degree angle that I cut, and it's just about dead nuts on center. I don't know if you'll be able to see it or not. This is the inlet. This is the air inlet, and there's a spring. There's a little valve that I make that's got to pass through. That's got to have a spring on it with a retainer, and it uses a cotter pin to hold that. But this part of the casting here is done. There's what they're calling an orifice cap that goes on here that I have to make, and that gets the hole in that gets tapped to 1/8 inch pipe, and it will screw directly on to the bottom of the cylinder head. Well, that's going to be a wrap on this part of the video. The casting for the fuel mixer, all the machine work on it is done, and my drill trick here for doing the valve seat, I believe, turned out rather good. Putting a 90-degree end on, grinding a 90-degree end on the drill, since I didn't have a 7/16 countersink But there's a needle valve in the compression fitting that I got to make for this here. I got to make the compression fitting for the fuel line for the inlet, which goes here. There's about 6 or 7 parts that I got to make yet for this. And then this part will be done. So this was about, all together was about, I spent about 6 hours on this here. Not all at one time, but probably all together. It's a pretty complicated little piece, and if you don't get it right, I'm sure it probably won't run. There's a little valve that goes in here, it comes through, it's got a spring on it, and I would assume that valve shuts the fuel off so it doesn't leak into the motor. And also when the cylinder sucks, it's going to suck up the valve to suck in air and fuel. There's no actual needle and seat or anything like that, or venturi or anything like a regular carburetor. So it'll be interesting to see how it works. So anyway, hope everybody's having a great day, and we'll see you in the next one. Take care. Bye-bye.